I believe people will keep joining. Let's start. We are losing our time. Once again, welcome you to this webinar on implementation of Trustzone on Armv8-M architecture. Okay, so I believe many of you are repeatedly you attend my technical webinars monthly. Thanks for your time and support. So, for the benefit of the team who has really joined this webinar, I'm Geeta.
Geeta, sorry to disturb you. Your voice is something like you are speaking some far away from the speaker. Could you please make sure that it will, so that it will be a bit clarified?
I'm talking from Bluetooth, so probably, but I'm in a cabin, so probably you're feeling like that. Probably I'll talk a bit louder. So, yeah, I'm Geeta. I work as technical director Armv8 for Arm Software Solutions in Jesus. So, we are the authorized and prime distributors of Arm Software Solutions in India. And basically, the webinar, usually monthly, we conduct is technical, nothing on commercial part, nothing on product. Basically, on the technology implemented by ARM or whatever the ARM technology currently going on, or the latest trends and technology by the ARM. So, yeah, so let's get started. Let me share the screen. Okay, now coming to Trustzone implementation on Armv8-M architecture. So for the benefit of the team, I would like to tell ARM, as everyone knows that Cortex ARM series was released by ARM as a breakthrough in the technology after they released ARM11 processor core, which actually did not come to embedded, but it went to Java enterprise application. So it has Jazera technology, so it never came to embedded application as such. So after that, ARM came with a breakthrough in the technology, which is Cortex A, Cortex RM, Cortex M, and ARM, all are 32-bit processor cores, and the architecture version was V8A, V7E, V7R, V7M. Okay, so today we'll be talking about V8M. So V8M is the advanced version of V7M. So V7M is again 32-bit core, unlike V7A. V8A also we had, V7R, but V8R did not come. So V8A was 64-bit processor architecture, but unlike V8A, Armv8-M is still 32-bit processor only, the 32-bit architecture. So V8M is the advanced version of V7M. So while we are talking about Trustzone implementation of V8M, so you may ask me why Geeta this Trustzone was not there in V7M or what? Why specifically I highlighted on V8M? So Trustzone was implemented by ARM from V8M architecture only. Having said that, Trustzone was the very old technology which ARM had implemented in Cortex A, but the Trustzone technology implemented in Cortex A was completely different from the one which is implemented in 8M architecture. Okay. So before I start, so please keep yourself muted. Any questions on specific slide, you can please put me on the chat. I'll certainly come back to it at the end of this session. So to avoid the noise and disturbance, please keep yourself muted. Thank you. So the agenda for today's webinar is what's the need for Trustzone? Why do you really need a Trustzone? Why at all ARM implemented Trustzone? If they would have implemented it earlier only, why they came up with V8M only? Why they implemented Trustzone for V8M architecture? Then definition of Trustzone. What Trustzone is all about? Comparison of traditional security methods. So when there are already security methods which are available in the market embedded domain, why did ARM come up with the Trustzone? How does this Trustzone work? So Trustzone is a technology from ARM. So how does it work? Is it on the practical basis, practical understanding on how does this work? Importance of Trustzone. how important it is, how critical it is. And lastly, the main topic of our webinar, which is implementing from Trustzone. Basically, if I directly come to implementing Trustzone, it like for the team who is not aware of this Trustzone word or Trustzone technology, it would have been difficult for them. So just 5 or 6 slides are covered. First few points, and implementing for Trustzone is where I'll be spending maximum time because that is the topic of our webinar. So need for Trustzone. So as the name suggests, secure your embedded systems. Now we see embedded systems from the mobile to the tablets or even to a small microcontroller application or a microprocessor application. So you see embedded systems everywhere, and embedded systems is growing. The complexity of the embedded system is growing based on the demands of the current world, current demands of the embedded market or requirement. As per the requirement, the system requirement for embedded systems or the design of the embedded systems is going complex high. And in that we have to secure our embedded systems, especially if your embedded system or whatever the product you are developing is going for some you're developing for an IoT application or for some payment application for anything. So security is a must there. Basically, security will ensure that there is no hacking happens, no data breach happens, no cyber attacks happen. So you can relate this to our mobile phone, correct? Our smartphone is now we use it not only for our own personal interest, we also use that for many other professional things as well. We also do the payment on smartphone. So we keep lot of information, confidential information, like could be your debit card pin, your debit card information, credit card information. So hackers can easily hack your phone as well. So security is very much important in an embedded system. Then we have to enhance your security with the Trustzone. So Trustzone will help us to ensure that the security can be implemented. Okay, Trustzone we can just as of now just take it as it's a way of implementing the security in your embedded system. How it is done in the coming slides we will talk about. So Trustzone is a technology which will help the developers to build the secure embedded systems. Okay, so if you select the Trustzone enabled processors, which I'll come to that later, you can easily implement the Trustzone in your application. Further, you can see the Trustzone lead in automotive security, mobile device security, IoT device security. Automotive security is to ensure that your vehicle, car or whatever it is, both the driver is safe and the passenger is safe. It also helps it for this ADAS, Advanced Driver Assistance System. Also, it ensures that your ECU, engine control unit, which is the heart of the automotive mobile or an automotive vehicle, is not hacked, which is not tampered, so that we can modify the functionalities of the entire car, and also ensure that the infotainment system, which is available in vehicle infotainment system given as part of your vehicle, is also not tampered. Mobile device, just now I highlighted about the smartphone. So we also keep our fingerprint in it. We keep the iris scan. We keep PIN, whatever. Some people use PIN, some use fingerprint, iris scan, whatever. So all such confidential information will be stored in the mobile. IoT device security is basically IoT, Internet of Things. Nowadays, more and more devices are getting into as part of IoT. Many devices are sending data to the cloud. So the data which is being sent to cloud is more vulnerable to be attacked by the hackers, because these IoT devices, the devices which are used to send the data to the cloud, edge devices, they are not very robust, they are low power devices, and these devices lack security. Means security is not paid much concern, or it is not taken into consideration for IoT. So the data which is sent to cloud, another device can hack that data. So we have to be very careful for IoT as well. So implementing Trustzone in such edge devices, we can achieve the security. So next, we'll see what is Trustzone. So ARM Trustzone is a system-wide.
Hello.
So ARM Trustzone is the system-wide approach to security, which can provide the hardware isolation for secure and non-secure areas of processors. So basically, ARM Trustzone will help you to basically provide the hardware isolation in your system. So it will physically it will isolate your non-secure areas of a processor.
करण्याच्या आधी मला एकदा स्टेप सांगशील, ओके?
Okay. Coming to ARM Trustzone. ARM Trustzone is a system-wide approach. Basically, it actually isolates your entire system into secure and non-secure physically. So it's a hardware isolation. So it's better and robust in comparison to software isolation. Even before Trustzone came into picture, users used to still implement a kind of isolation by using the software solutions or through programming from the software. Okay, so this started by security architecture. They helped the designers to build the secure application as well as the services on the ARM-based device. Okay. So this Trustzone technology, it's a hardware-based solution, as I explained. It can be scalable, means it can be deployed, it can be used across various wide range of devices on wide range of applications. Okay. So this was just the smartphone thing which I was telling about with the picture. So comparison with traditional security methods. So as I told before, ARM came up with a Trustzone. The developers used to still ensure some level of security with the help of developing or implementing the security on their device through the software. Okay, but that was easily hackable. Means the data breach or the cyber attacks or the data would have been it was hacked by the hackers. So only ARM came up with a hardware level isolation where it is very difficult for the attackers to pass through that isolation. Okay, physically it separates the device, your embedded device to two worlds, secure and non-secure worlds. Still talk about that. So Trustzone also has several advantages over traditional security methods. First thing is hardware-based security. Because the entire memory or the entire system itself is divided into two different states or worlds. We call it as secure world or non-secure world. Isolation. So isolation here is done on even the memory and the peripherals level. So scalability. So scalability means this Trustzone can be implemented from the lower end device to higher end device. Okay. Armv8-M also we have many devices, so you can implement for that. Cost effectiveness. So any manufacturer, I'm talking about the semiconductor vendor who is developing the V8M based microcontrollers, they can also implement the Trustzone technology in their device, because implementing Trustzone is again a costly affair. So again, Trustzone application, they can still implement the Trustzone in their device and achieve this security with a very cost-effective solution. So flexibility is Trustzone can be used for, so it can be used on any device, and that device can be used for any application. It can be automotive, IoT, medical. It can be used in any application where security is a concern. So here you can see it can be used to secure the sensitive patient data, such as health records and all, for the personal medical information. So how does Trustzone work? So Trustzone, as I told, it's a hardware extension technology. developed by ARM. Doesn't mean that all V8M cores should have Trustzone. It is implementation specific again. So the silicon vendor or the semiconductor vendor who has licensed this ARM V8M core from the ARM will decide whether they have to implement the Trustzone feature in their device or not. Okay. So especially it splits the hardware into two worlds, a normal world and a secure world. Okay. So this particular technology is supported in Cortex-A as well as Cortex-M. But the technology implemented in Cortex is a very higher end and it's a different compared to M, because M stands for microcontroller. So when ARM designed trust technology for Trustzone technology for Cortex-M, so they have kept in mind about the inbuilt features of Cortex-M. Why will a user, why will a developer go and pick or select Cortex-M? Basically for deterministic behavior, low latency, real-time behavior, low interrupt latency, and for microcontroller profile. So keeping in view of all these points, ARM designed Trustzone for Cortex-M. Don't think that same Cortex-A technology, which was Trustzone technology for Cortex-A, was extended to the M. It's totally different. It was developed from scratch for V8M. Okay. So secure state is usually the secure state is where you want to store some sensitive operations. Like I told, for mobile, you want to store your debit card information, PIN, which you use for doing the transactions, or it can be related to your fingerprint or anything, some personal information, confidential information can be stored in secure state. Whereas in a non-secure state, your user application or a normal applications can run. Okay. So this hardware separation between the two states can be achieved through hardware as well as software. First, through hardware, Trustzone will give you the isolation, physical isolation between the two states, secure and non-secure. Further software, using software mechanisms like MPU, I'll come to that, memory protection unit and other blocks, we can still achieve the next level of security, or we can make use of the advantage of this Trustzone and using by the software, and we can implement the next level of security. Okay. So how does Trustzone works? There are different versions which have been defined in ARM architecture, which I told already. Armv7, this is for Cortex-A, Armv7-A, Cortex-A9 and M4 by V8. M4 did not have any, M4 is a V7-M architecture that did not have any Trustzone at all. Whereas V8, we have V8A and V8M. So V8A, here it is seen, A53, A57. These both are 64-bit processor cores based on V8A architecture. But here, as I told, V8M, Trustzone implementation on V8M was designed keeping in view of microcontroller application. And here in V8A architecture, it was different, where it was based on virtual memory system architecture, VMSA we call it as. Because there in Trustzone for Cortex-A, it was virtual memory based, especially for Linux application or Android application and all. The applications run as if it's running in its own space. So finally, that application has to be mapped onto the physical address on the hardware. So this Trustzone implementation in Cortex-A is a complex one compared to V8M. Okay. Another important feature of Trustzone is cryptographic extension, which was there in V8A, that is not there in V8M. V8M don't require any cryptographic because many of the silicon vendors, they come up with, what is that? Cryptographic supports which is encoding and decoding algorithm, EES algorithm for all, for security implementation. Next, what is the importance of ARM Trustzone? So ARM Trustzone is a de facto technology which is very much required in today's digital world, where the data breaches and cyber attacks are being increasing. It's basically required to secure your devices mobile phones or IoT, where the devices like mobile for smartphones, it's continuously for 24 hours, it's connected to the internet. So hackers can easily hack your phone through net if the security is not there. So for such devices which are continuously connected to the net, like mobile phones or Internet of Things or data servers, that is for high performance computation, data servers. So for all those, Trustzone security is a must and Trustzone has to be implemented. So this protection is critical because some companies also, like if the data hackers have some important information related to the company, it will be the loss for the company, financial loss, and Trustzone allows storage of such confidential information, everything, and normal world application or hackers cannot access that information. So by using Trustzone, manufacturers can add a hardware-based security layer to their IoT devices. So as I told, IoT devices are the edge devices which sends the data to the cloud. They usually are with a low footprint, not much performance-wise, like it's a small, you can take a lower end microcontroller device which you've been selected that does not have any, which will be lacking the security feature. So by the silicon vendors who develop such devices, if they implement Trustzone, it will be easy so that even the IoT application or the hackers cannot hack the data sent by the IoT devices. So Trustzone also provides the secure boot. So if at all you are selecting a Trustzone enabled processor, like Armv8-M has a Trustzone implemented. If at all you are selecting the Armv8-M processor, like I'll tell you M23, M33, M85, M55, all these are based on Armv8-M architecture, Armv8-M processor core. Basically, ARM came up with Cortex M23 and M33 specifically for IoT applications, because many of the customers in India are using Cortex M devices for IoT application. And if you take Armv7-M and all, there was no security implemented at all. So specifically for targeting such applications or for IoT specifically, ARM came up with Cortex M23 and M33 processor cores, which are 32-bit processor core again, with the Trustzone implementation. Okay. So similarly, also have M35P, M55, M85. All those are Armv8-M architecture with the Trustzone enabled. Okay, even ARM came up with the specific architecture M85 or something, or M55 specifically for AI and ML workloads, artificial intelligence and machine learning workload, basically for robotics application. So just as additional information. So if at all the user developer has selected the Trustzone enabled processor, like M23 or M33, then the processor, when you give power on, it will always boot from the secure mode only. It will boot from the secure mode, and then if required, it will go to the non-secure mode. But it will first boot from the secure mode. It also allows secure boot and secure firmware updates. So this will also ensure that whatever the firmware or the software you are programming into the secure memory is being authorized, is being authenticated. So that even if the hackers enter the normal state of execution, they cannot enter the secure state. Another main advantage feature of ARM Trustzone is this ARM technology is widely recognized and adopted by the regulatory bodies such as NIST, PIPS, and safety regulatory bodies. So this will help the users or developers to select the Trustzone enabled devices, and they can use these devices for wide range of applications such as healthcare, finance, and government, because this technology is already being recognized and adopted, accepted by the safety regulatory bodies. So now come to the actual topic of implementation of ARM Trustzone. Okay, so this webinar is probably more on a theoretical part because how it can be implemented is what I'll be covering. So to implement an ARM Trustzone, okay, suppose you are selecting a Trustzone enabled processor, or you are trying to implement an Trustzone, probably a silicon vendor for a different processor, because Trustzone is an IP again separately. So we have to first identify there are some criteria, some points we have to take into consideration. We have to identify which parts of the system requires, which parts of the system of your current system needs to be secured. What data has to be secured, which part of your system has to be secured. Then you have to define a security policy for that. And then you can use configure MPU to configure the memory protection unit if defined. Because MPU is again implementation specific. And silicon vendor will design whether MPU has to be there in the microcontroller or not. Then configure the MPU to ensure or to achieve that security policy what you have defined. And then you write the software for secure world and non-secure world. And then you can test your system. So this is the for implementation of Trustzone, these are the points considered. So coming to the first point in the slide only, I told it's a hardware isolation. It physically isolates your system into secure and non-secure. So it can be secure and non-secure means it can have non-secure memory, secure peripherals, non-secure peripherals, even the modes of the execution. Like because V8-M Cortex-M architecture again, it operates in two modes, handler mode and thread mode. So secure mode also can have processor can operate in two modes. Non-secure mode can also operate in two modes, handler mode and thread mode. So usually for V8-M architecture with security extension means which has a Trustzone implemented. These are some of the things which can be those critical components. It can be placed in the secure world, can be a bootloader, secure bootloader, some secret keys, algorithm keys, flash running support, and some high value assets. This can be some personal information or confidential information related to banking or whatever you can keep it. Okay, so security systems of a secure platform. So to implement the Trustzone in the software or to use the Trustzone enabled processor. So what all criteria, security requirements are required? The bus protocol has to be extended to support the security attributes. So the bus means it can be NAM. I'm talking about AMBA bus, AHP or APB bus. Let's talk about AMBA bus because that's the bus which is inside the chip processor core. So you have a dedicated protect bit for the ARM bus, which will decide whether the processor will be accessing secure or non-secure. In case of V8-M, depending on what address the processor is accessing, based on that whether the address falls in secure mode, secure state or non-secure state, the processor will access that memory. Okay. So extra components also requires to manage system security, basically to access the permissions for secure and non-secure peripherals. So as you know, any peripherals which are defined in secure mode, non-secure mode cannot access those peripherals. So we can also, like access means it can access as a read only, not a write permission. So we can also assign the permission like read access with no write access. Like that we can set the access permissions. And debug architecture must also be taken care so that the hacker should not be able to enter the secure state through the debug mode. And the developers who are developing the software to be run on the secure world has to be written very carefully. Once the code is written carefully and the code is stored in the secure memory, your code is protected, or even your data is also protected. No one can hack it. So what is the design characteristics? The design of Trustzone technology has several key characteristics. Okay. So what are those? a code which is running in non-secure mode can call secure functions only through valid entry points. We had in Cortex-A-SM secure monitor. So there, the switch between the secure mode to non-secure, non-secure to secure was through the secure monitor, which was processor used to execute secure monitor as a part of interrupt handler or an exception handler. Okay, there you had only one entry point from non-secure to secure. But here in V8M, we have multiple entry points, but these should be valid entry points. There you have SN, here we have SG, secure gateway. So as the name suggests, that's a gateway from where the normal code executing in the normal world can enter the secure world. Okay. So there are further criteria. So I'll come to that. And there should be low switching overhead, means switching from secure to non-secure or non-secure to secure, vice versa. There should not be much overhead on the processor. It should not take extra clock cycles for that. And whenever non-secure interrupts, when the processor is executing in secure mode, and if some interrupts are generated in the non-secure mode, then the secure mode has to still service those interrupts. This is to ensure the low latency, which is the feature of Cortex-M processor. And if you are using the Trustzone enabled processor, as I told, the processor always starts in the secure state by default. So this ensures the root of trust implementation for the secure boot. The same thing, design characteristics extended, low power. So though the isolation you have secure and non-secure mode, but the register bank is not separate here. Same register bank is used for secure mode and non-secure mode. So for the purpose of the team and tell register banks, we have 16 register banks, which are 32-bit registers. In that R13 is stack pointer, R14 is link register, R15 is program counter. All other registers are general purpose registers. Okay. So in case of here V8M, there is no separate, this means the register banks are not banked. The same register bank is used for secure and non-secure, considering that, however, the code executed non-secure cannot snoop or cannot check or access the data or even modify the data which is stored on the register bank for the secure mode. Or secure mode is storing some data in the registers. So non-secure mode cannot still even see that. So interrupt handlers are still can be written in C. Okay, high flexibility is and suppose on the secure mode there is some code executing which is a middleware or a kind of a code which requires some resource, some drivers from the non-secure mode. So secure mode can easily access the data or a code from the non-secure mode. So now coming to memory system partitioning. So as everyone know, for Cortex-M, ARM has given 4 GB memory space. And this memory itself is partitioned into non-secure and secure memory regions. Okay. So non-secure means, as the name suggests, all your user applications will be executing in non-secure mode. So any software which is running on the device can access this addresses non-secure because it's accessible for the any part of the program or any part of the software running on the device. Next, we have secure memory. Secure memory is again divided into 2 types, secure and non-secure callable. So secure addresses, again, we have separate secure memory for code or data and peripherals memory. So both similar to non-secure, but we also have non-secure callable. Non-secure callable means this memory is specifically provided in V8M basically for the user, for the code executing in non-secure mode to access the secure mode. Some memory location which the non-secure code can access should be part of non-secure callable. Suppose if the non-secure code is accessing the memory from the secure memory, then the fault exception will be generated by the processor. If at all you want, if the user wants to give the access for some of the memory locations access to non-secure mode, then that memory location should be configured as non-secure callable. So who will decide this secure memory to be divided into secure and non-secure callable? It is through security attribution register unit. I'll come to that. So this memory also holds SG, secure, which is secure gateway. Okay. Only this secure gateway instruction has to be placed in this non-secure callable only, memory only. Secure gateway instruction should not be placed in secure memory. Linker, the compiler what you are using, when you are writing the program, the linker has to ensure that the SG goes to the address which is designated as non-secure callable. So only its name non-secure callable. NSC means this memory is accessible by non-secure. Further, NSC memory regions actually contain येलो एड्रेस तो हमारा 107 ही है. इसके साथ हमारा और एक ऑफिस है, सिर्फ वो एक रोड के बाजू में 147. नहीं, ये तो डिफॉल्ट भेजते हैं सारे ऑर्डर एक्नॉलेजमेंट्स के लिए. वो लेटर ऑफ अश्योरेंस है, वो आपको देना पड़ेगा. वो बस आपको ये है कि इट्स लाइक अ काइंड ऑफ डिक्लेरेशन जो आपको सैमसंग लेटर हेड में डाल के साइन करके देना. So the secure gateway instruction has to be called from the non-secure mode only, or the code executing in non-secure state. But this SG has to be stored in the non-secure memory. That is the mandatory thing, prerequisite. Okay. So when a non-secure program calls a function in the secure side, the first instruction in the API will be SG. Okay. So this secure attribution unit will further define or divide the secure memory to secure memory and non-secure callable memory. Okay. So here you can see address. So this is your 4 GB memory address or whatever, which is already defined, divided into secure and non-secure. So if you take this, the secure attribute unit, security attribution unit, or IDAU, implementation defined attribution unit. If the implementation defined means if at all the is defined or present by the is being available in the microcontroller, then using the security attribution unit, the secure memory can be further divided into secure memory and non-secure callable memories. So now coming to banked internal resources. So we spoke about register banks are not banked. So similar same register banks are used. But now we will talk about the internal resources or some of the system registers which are banked. So the two states, normal secure mode and non-secure mode, has its own stack pointer and stack dedicated. And you have banked SysTick timer. SysTick timer is a on-chip timer 24-bit down counter which generates the interrupt when it reaches the 0. We have NVIC, nested vector interrupt controller, to support this nested vectored functioning, interrupt handling support. We have secure or status control block, we call it as, we have MPU. So all these we have banked form, means you have secure SysTick, we have non-secure SysTick. Like this, you can see all green are secure, all red are non-secured. Okay. Not only the secure mode has this own set of registers for this system control functions, but it can also access the non-secure MPU, SCB, whatever the non-secure MPU, system control block, NVIC stick, it can access those by using the alias feature. So memory alias feature is the feature which is implemented by ARM for Cortex-M memory map. Some memories are mirrored in the alias region, and there the processor can access the same contents from that alias memory. The same feature is used in V8-M, where the code executing in secure mode can have access to its own secure version of the registers. It can also access the non-secure version of the registers by using alias. The same non-secure version of the registers can be accessed through the alias. Now you see the example memory map here. As I told, ARM for Cortex-M, ARM has given 4 GB memory map. This is the 4 GB memory map from 0 to 8Fs. So you 0th address is a non-secure flash. In that, you also have some secure flash and non-secure, again non-secure RAM, secure RAM and non-secure peripherals, secure and non-secure. Other than that, off-chip memory, off-chip peripherals, all this here is again for that bank. But off-chip memory can still be, it's not like it doesn't have separate secure and non-secure and off-chip peripherals. There is software developer has to pay attention and ensure that normal mode execution or non-secure mode will not access some data from the secure mode. Okay, secure and non-secure MPUs. So after this security attribution unit or implementation defined attribution unit defines or divides the memory into secure and non-secure callable, then we can have the MPU. MPUs are in implementation defined. Not all microcontrollers are MPU, basically to reduce the cost, reduce the overall power consumption. Silicon vendors sometimes may not include MPU, but if you have MPU, again you will have secure and non-secure MPU. That MPU will be then divided into secure and non-secure MPU. So depending on what address the processor is fetching, it will processor in which mode it is, based on that it will go and access that specific address. So for the benefit of the team, I would like to tell MPU is memory protection unit. The same memory map of Cortex-M can be further defined into regions. 8 regions it supports, and each region has its own size and base address. And each region we can give the access permissions, whether it is read only, write only, or execute or not execute never, like that we can set the access permissions. Thereby we can protect the memory. So last but not the least, for the implementation of the Trustzone, when you are selecting a V8-M processor, suppose you are planning to use Trustzone application or you are planning to implement security in your application, and you have selected a Trustzone enabled processor. So what are the key criteria you have to keep in mind to select that? First is the performance of the processor and the overall power consumption, which everyone takes care. Availability of the development tools and support. So here is where our role comes. Development tools is required compiler, software, JTAG debugger for programming the code to the board and doing the real-time testing, real-time debugging, and code coverage for calculating the power consumption, all those. So here is what we play a role. We give this development tools and support. Then depending on what processor I've selected, what is the documentation available, any reference design available. So all this comes next. So this is how, there's a practical approach on how you can implement a Trustzone, how the Trustzone can be implemented on an V8-M architecture. So this is my mail ID and cell phone number. Anyone has any questions, please reach out to me, but I'll be coming to the chat now. I have to stop sharing. And then I can come back. What is the hardware requirements of Trustzone? Does it load controller? Does it load controller processor code? I'm able to understand this question. Hardware requirement, see, Trustzone itself is a hardware security implementation. You don't require any hardware for it. If you select a Trustzone enabled processor, everything is taken care of.
No, my
You
question
have,
is like if a controller or a processor has a trust zone, and if we do not enable it or if we enable it, does it has any performance differences?
if your security, if you need a security, then you have to enable it.
That's right. Like if we need a security, we will be enabling it. But much is the processing speed that it will take from the core or the process?
Go over the, please wait. You need not answer me. Okay. You can answer me on the chat. Okay. Coming to Trustzone is actually the feature available by the ARM, which is given by ARM, and it's implemented in V8-M architecture as well as V8-E7A, as well as V8A architecture. Okay. It depends on the requirement. If your requirement is, I want to get in a security firm application, then implement Trustzone. Okay. So the power consumption and all you have to take into consideration because, and it is not loading processor or controller because if you are selecting Armv8-M processor core, it's not that directly you are selecting V8-M for your application. You'll be going to the microcontroller. Like we have the main microcontrollers from Nuvoton, we have from NXP, we have. So there are silicon vendors who are giving the microcontrollers based on this core. So when you are selecting the microcontroller, the load will be on the controller only. But instead, if you're not going for a microcontroller or designing your own design using just the processor core, then the load will be on the processor core. Between MPU with integrated Trustzone versus interfacing with an external HSM, which provides more security. Sanjay Dave, are you working on Horix microcontroller? Some. Please respond on chat. I don't want on call. Okay. HSM is a hardware security module, which I have come across. As per my knowledge, probably it can be in other also. As per my knowledge, it is used in Oryx processor. So hardware security model is nothing but the M3 core, and HSM is the Cortex M3 core from Infineon. Okay, that there is no part number or something on that, but Infineon uses because they also have microcontrollers based on M0 and M4 core, that is XMC 1000, XMC 4000 series. But M3 core base, they don't have any microcontrollers. They have not designed, and with those microcontrollers are not available in market. They have not come up with any microcontrollers based on Cortex M3. We do have TLE series that is specifically for automotive application. That is different. I'm talking about XMC series. So this hardware security module is based on the M3 core. Okay. So now coming to your question. Between MPU with integrated Trustzone versus interfacing with the external HSM. See, HSM is again hardware security module, and it is again till M3. So M3 doesn't have Trustzone. And whatever the security you're getting there, as a name suggests, it's a hardware, but I'm sure, as I know, hardware security module is basically to ensure that the device or whatever doesn't get tampered, as per my knowledge on HSM goes. But here Trustzone is implemented for V8M and V8A architecture, or V7A architecture is basically it's physically hybridly isolating your code itself or your secure data itself. So you cannot compare Trustzone with an HSM, because HSM is again M Cortex M4 based only, but that is M3 based. Probably HSM, yes, you can get security to some extent, but next level or advanced security you can get with Trustzone only, because M3 did not have any security feature inbuilt in it. Probably Infineon might be using MPU. Is there any vulnerability identified so far during secure booting? No. Because processor directly boots from secure booting, and when the processor is executing in secure mode, hackers cannot access secure mode. So there is no attack. If the requirement is high computation and security, any recommendation like 4 clock speed and internal memories, that you have to refer to the device datasheet, depending on your application. Clock speed, core and all. What is the difference between Trustzone and Trustzone? Yeah, I believe Nawaz answered this question at the beginning of the webinar. Trustzone is the same concept, the technology is same. Okay, that was first implemented in Cortex A series. Then it was extended to Armv8-M. I don't want to tell Cortex M because Cortex M we have V6M, V7M as well. So I'm specifically telling V8M architecture. As I told, the Trustzone on Cortex A was a very complex thing, and it had only one entry point, which was secure monitor, and it was shifting between two worlds was through interrupt execution. But here you have multiple entry points, which is secure gateway again. But this secure gateway again, though it has multiple entry points, there is also a checker for every entry to the secure gateway to ensure that the non-secure mode code is executing, secure gateway is executing in a correct way. And basically, Arm designed this Trustzone technology for V8M from the scratch. From starting, they started. They did not bring the same V7 Cortex A Trustzone to V8M, because there Cortex A is specifically used for higher end application, for high performance, high computation, which Govardhan is asking. There, where a large volume of data has to be processed and all, for high performance application or kind of SOC application, Cortex A is used. But whereas Cortex M stands for microcontroller, for lower end application to higher end application, though it doesn't. We don't want to restrict M2 for higher end application. It can, because M also has processors, comes with a higher processing speed, operating frequency and all. But M, we keep it as microcontroller profile, and it can be used for microcontroller application. As M was designed specifically for low interrupt latency, real-time deterministic behavior, real-time behavior. So keeping in view of those, Arm came up, Arm designed the Trustzone specifically for V8M, keeping in view that it has to be going to the M microcontroller architecture. Is Trustzone a driver and how to communicate? Trustzone is not a driver. It's a technology which is, if you select a Trustzone based device, it's already there. You have to just program the Trustzone through registers. For V8M, Trustzone has to be programmed to registers. It's there. You have to like first divide your memory. So like using a security attribution unit, SAU block, there are registers associated with it. Define the secure memory and non-secure callable memory. So rest of the other memories is used for non-secure mode. So Trustzone has to be programmed using the registers which are provided by the microcontroller. Any other questions? This recording will be uploaded on the YouTube, so you'll get to see it soon. So no questions. Thank you so much for your time, for making up for this webinar. And please stay tuned. Every month I do technical webinars. So next month I'll again come up with some topic related again some ARM technology only. Okay. So take care. Have a pleasant evening. Bye bye.